So if you know the basic curve, you know y equals function x, then you can make a new curve. The first idea was shifting the curve, moving it. So if you get y equals function x plus or minus a, that's when you're shifting the curve vertically. Another way of thinking about that is it's grouped with the y value. Yes, normally we write it as y equals function x plus or minus a, but I can move that a over to the other side. So I can group it with the y value. So because I can group it with the y value, it's the y value that's affected, and that's why it moves up or it moves down. So shift a units up, replace y with y minus a. If ever you're trying to work out what the shift is, when it is grouped with the y, you just look at it and say, what would make this equal to 0? And that tells you how much you shift. Okay. So here's a random curve. Random curve. Y equals function x. If I was to shift everything up a, there we go. They're all going up a. Whoop, we get that new curve. Function x plus a is how we normally see it. But as I say, if it was grouped with the y, I'd have y minus a equals function x. What makes y minus a equal to 0? Oh, a does. So that's basically where the origin or would have been moved. Or not the origin, the x-intercept, because it would have gone up to a. If it is grouped with the x, now we have a horizontal shift. So it's got to be in parentheses, grouped together. This one's a more obvious one because you see the grouping. And then it'll be left to right. Again, what makes it equal 0? So if I was going to move everything to the left, that would be the shift plus b. Again, it's x plus b, because what makes that equal to 0? Negative b. So we're moving 0 left to negative b. Stretching curves. If we multiply a function times a constant, again, this is with the y value, because I could move that k and put it with the y. So it's the y value that's changing. So it's a vertical stretch, because I could rewrite it as y over k equals function x. If k ends up being greater than 1, we get a shallower curve. K is greater than 1, we get a steeper curve. So, whoop. If k is greater than 1, I'd get every y value, and I'm making it bigger. So I'm stretching it up. But if k was less than 1, then I'm compacting it, I'm pushing it in. Notice the x-intercepts don't change, because I'm not playing with the x values. It's the y values this is changing, not the x values. Domain will remain the same, that's not going to change, because domain's to do with x values. The key points of the x values will stay, their y values will change, unless it's 0, of course. And the x-intercepts, and that's why the x-intercepts stay the same. So if it was grouped with the x, that's now when it would be a horizontal stretch, because now it's the x value that's going to be affected. Okay. There we go. So this time, if it's less than 1, I would push it in. Now, how do I know that? Because I'd say, well, let's imagine this x-intercept of the blue curve was equal to 1. I've now got x on k. So what would make x on k equal to 1? K. But k is less than 1. So I'm pushing it in to k. But if k was bigger than 1, then I'd be pulling it out. Because I'd then say, oh, what makes x on k? Whoop, there we go. Notice over here, I've rewritten it. If you see this, because you don't normally see it as k, x on k, sometimes you'll see it as k times x, and that's where it gets confusing. And so in this case, the capital K would be bigger than 1, would make it push in. But just ask yourself the question is, how would I get back to that original curve? And then that'll tell you, have I pulled it out or pushed it in? So in this case, the y values, all those key points, the y values are staying the same. So my range is staying the same. But it's the x values that are changing. Reflecting curves. Y equals negative function x is a reflection in the x-axis. Let's reflect it. Because what we're now saying is, everywhere it was positive, it's now negative, and everywhere it was negative, it's now positive. And so I just plot the key points, reflect them in the x-axis, and then, whee, there we go, look at that. As y equals negative function x. Where if it's function negative x, that'll reflect in the y-axis. Because again, it's now the x values that I'm playing with. So I'll swap those over. The y intercept stays the same. Swap them over. Oop. And get the key points. There we go. That would be function negative x. Now you've got to be careful when you're looking for function negative x, because of course when you square negative x, you get positive x. So it's not immediately obvious that you're looking at function negative x. Things like that. Function 2a minus x. What do you reckon that does without looking at the sheet? It's still a reflection vertically, but I've shifted the curve. So it actually ends up being a reflection in x equals not 2a, but x equals a. Because you're reflecting, that's why the a gets doubled. Okay? Because what you do, you replace x with 2a minus x. So let me have a look. Here's our random curve. There's x equals a. So that point would stay the same. Because if you substitute in, 2a minus a gives you, so it hasn't changed. Okay, so that's why it's 2a minus. But every other point will be reflected in the line x equals a. And there you go, we'd end up with something like that. There's function 2a minus x. So you can still reflect, not necessarily in the y-axis is what I'm getting at. Why is it reflected in x equals a? Because we're saying which point would stay the same. If I substitute into 2a minus x, what do I substitute into x and still get the same answer? And the answer is a. So that's where I reflect, because on that line it doesn't change. Everything else then reflects. I mean, the horizontal reflection is easier because we've just shifted it up 2a and then reflected it. So it'd be 2a minus function x. So, whoop. There we go, let's draw that one. And if I was to reflect that line in y equals a, why is that one about y equals a? Hang on. Because you're saying what would make the y value the same. So 2a minus y equals 2a minus function x. Function x is equal to y. So it was the original y value. But it's the same idea, I guess. But I guess imagine that I swap the x and the y values around and would draw its inverse curve. And then group with the y. Well, it'd have to be y minus 2a, not y minus a. Okay. All right, well, just a handful of questions there to have a go at that idea.